Welcome to Lesson 1-1, writing repeating decimals as fractions or rational numbers. This is important. Why do we do this? Because repeating decimals are actually difficult to work with in computation. Fractions really aren't that bad. They're easier to add, subtract, multiply, and divide with. So let's go ahead and get started with our first example. We want to turn 0.4 repeating into a fraction. A 0.4 repeating is actually 0.44444 continuing on forever and forever. It's repeating. So the process that we're going to solve is these 5 steps over here, and these 5 steps are the same no matter what our situation is with our repeating decimal. And we're going to see several different situations. Let's go ahead and begin our process. Hopefully we can start to see some patterns. And sometimes those patterns can be used and sometimes they can't. And so we'll see over the next couple of lessons when we can use those and when we can't. So our first step is to write the decimal as 0 point something, and it already is 0 point something, so we're good there. We're going to set up an equation. Our equation is always going to look like this. X equals 0 point, and whatever we have here. So we have 4 repeating, but we want to actually repeat the repeat. So since a 4 is repeating, we're going to write that one more time. You'll see why here in a second. We're on the first step. That's all there is to it. This is the equation that we're actually going to manipulate, use. It's going to help us see what our next things are going to be. We're now ready for step number 2. We're going to move the decimal in this equation to after the repeat, but in order to do that, we have to follow our rules of equivalence, and we're going to multiply both sides by the appropriate power of 10. Let me change color here so you can actually see what's going on. So I want to move the decimal here, where it started, to after the original repeat. So the original repeat was before the 4, and now I'm going to move it to after the first 4. So now it's going to be there. Well, how did I do that? In order to make that happen, I actually need to multiply this side by the first power 10, 10 to the power of 1. This is 10 to the power of 1. If I multiply this side by 10 to the power of 1, I need to multiply the other side by 10 to the power of 1. Well, that's just 10. So 10 times x is 10x equals, and then to figure out what this side of the number is, we just look to see where we moved our decimal to. We moved it to between the two numbers. So instead of the decimal being here, it is now here. And so our number is actually 4.4 repeating. Oh, my decimal did not show up. There we go. And now we're done with step number 2. Let's go ahead and move on to step number 3. In step number 3, we're going to move that decimal in our original equation we wrote to before the decimal, or before the repeat, sorry. And if necessary, if it is necessary, let's check. Well, the decimal actually started out right before the repeat. So our second equation that we're going to write in this work to solve is the same equation that we started with when we were trying to manipulate. So it's x equals 0.4 repeating. The same thing we started when we started writing up here. And these are the 2 equations that we're going to work with. In step number 4, we're going to subtract the equations. Not this one. This is the one we were just playing with, trying to figure out where does the decimal go, how many times do I have to move it. So now we're going to subtract. So 10x minus x, well, remember this is just 1x. So 10x minus x is actually 9x. We can do that because these are like terms. And over here, this is where the magic starts to happen. So the decimal should line up. We need to subtract place value. And here what we have is 4 repeating minus 4 repeating in this place. Well, what happens when I subtract something from itself? When I subtract something from itself, I end up with nothing. So this repeating part actually cancels out. And that was my goal, get rid of the repeat. Now that I've gotten rid of the repeat, I just have 4 minus 0. So I get 4. Hey, look at that. No repeat. Life is grand. This is just like an equation that you solved in both 6th and 7th grade. So now we're ready to solve for x and simplify. To solve for x, I have 9 times x. To get rid of multiplication, I'm going to divide. I'm actually using the fraction bar here. My goal is to get a fraction. I'm going to divide. 9 divided by 9 is just 1. And so I get x equals 4 ninths. Remember, do not get a calculator out here. I want a fraction. That was my goal. So I've solved for x. X equals 4 ninths. That means 0.4 repeating then is 4 ninths. I do want to simplify that, but that has already been simplified. 0.4 repeating is equal to 4 ninths. If I went too fast, make sure you hit the pause button, repeat, make sure your notes look like this. Let's try another one. Let's see if we can do this. Hey, you don't have to wait for me if you're trying to solve this. If you think you can do it on your own as you're going, go ahead and try it and then see how you do. So again, I'm looking at 0.7 repeating, 0.7 repeating. So I want to rewrite that decimal. Already is. It's already there. So I am going to set up the equation. And my equation is x equals 0.7. And then I'm going to repeat the repeat. The 7 is repeating, so I just repeat it one more time. And then I'm going to move that decimal to after the repeat. Move that decimal to after the repeat. So the decimal started here. I'm going to move it to after the original repeat, right there. Not after both, just the original. Okay, I moved it one time. That was 10 to the power of 1. So in order to make this an equivalent equation to what we had originally, I just need to multiply both sides by 10. So 10 times x is 10x. And we can see here when I move the decimal here, now I actually get 7.7 repeating. And then I'm ready for the next step. Step number 3, move the decimal to before the repeat. Well, it started to before the repeat. So I just write the original equation. X equals, notice I'm lining everything up. X equals 0.7 repeating. And now I'm ready for step number 4. Subtract my equations. 10x minus 1x. 10 minus 1 is 9. Don't forget your x. Equals, over here, the decimals lined up. My repeating portion also lined up. 7 minus 0 is 7. And now I'm going to solve for x. 9 times x, so I'm going to get rid of multiplication by division, divide by 9, divide both sides by 9, and I get x equals 7 ninths. 7 ninths is a simplified fraction, so 0.7 repeating is the same thing as 7 ninths. Recording. Okay, so if you needed more time, make sure you hit the pause button. All right, let's try another one. Actually, let's make a prediction. What pattern did you see? If the repeating number is 0.5 repeating, what would the numerator be? What would the denominator be? I don't actually want you to solve this with the method we just did. I want you to use what we just found in the previous 2 examples to figure out what would this answer be using a prediction based on the pattern you just saw with the previous 2 examples. So take a moment to figure that out and then enter that into the system. See what you get. Okay, let's see if your answers matched mine. So you know that 0.5 terminating is 5 over 10, and hopefully you discovered that 0.5 repeating is actually 5 over 9. So when there's 1 digit repeating, you should be able to take the number, put it on top as the numerator, and then the denominator is 9. Now, given that information, and you know that 0.29 is 29 over 100, you just take those 2 numbers, put it over the power of 10 based on the number of digits that for that terminating decimal. What fraction do you think 0.29 hundredths will equal? What fraction do you think 29 hundredths will equal? What's the numerator? What's the denominator? I want you to take a moment and see if you can figure out that answer and go ahead and enter those information. Hey, this is a prediction. If you're right, great. If you're wrong, that's fine too. We are making a prediction. We're going to solve it here in a moment. So go ahead and take your time, see what you get there. And now let's take a moment and figure that out. We're going to use our steps to see if we can come up with this answer. Same process as before. 0.29 repeating. Write the decimal, set up our equation. Okay, it already starts with 0, so x equals 0.29. Repeat the repeat. 29 is repeating. 29 would continue on forever and ever. Move the decimal to after. The decimal is here before the 29. It needs to move. Oh, I did not change the color here. It goes to after. So it's between the 2 29s. Well, how many times did I have to move it that time? I actually had to move it twice. So it's 10 to the power of 2. 10 to the power of 2. So 10 to the power of 2 is actually 100. So 100x equals 29.29. 29 repeated. Notice that decimal is now in between the 29s, so my answer here is 29.29, multiplying both sides by 100. Okay, let's try the next step. We're going to move the decimal to before the repeat. Okay, again, before the repeat is actually where it began. So I'm not multiplying either side, it's just the original equation, x equals 0.29 repeating. Now we're going to subtract. Again, this is 1x, 100x minus 1x, 100 minus 1 is simply 99x. Did my decimals line up? Sure did. 29 hundredths minus 29 hundredths, repeating, by the way, here. And yes, they're both repeating, so yes, they're the same. They cancel each other out. 29 minus 0, 29. Solving for x, we would need to divide both sides by the coefficient of x, which is 99. The 99s cancel each other out. That's actually 1. So we have 1x is equal to 29 over 99. Is that what you predicted? 29 hundredths repeating is 29 over 99. Is that what you figured out? Let's see here. We know that 29 hundredths repeating is equal to 29 over 99. We also discovered that 0.5 repeating was equal to 5 over 9. So did your prediction match the actual results? Again, not your bell, just in the recording. Based on this result, what rule can you write? What rule can you write when all digits are repeating after the decimal? Think of what is the rule for the numerator, what is the rule for denominator, and be ready to share that in small group. This would be a good time maybe to talk with a friend or somebody at your table and see if you come with the same conclusion. So maybe you can figure out, what would this be written as a fraction without having to do any of that work? Can you figure out what the rule is? Excellent job. Into the first video.